Hello grade 11, welcome again in our online sessions with you Mrs. Minna Raouf, your chemistry teacher. Today we will continue explain chapter 18 organic chemistry. In the last session we explained together the first group of hydrocarbons that called alkanes. Today we will explain alkenes and alkynes. And I told you that the unsaturated hydrocarbons is two main groups, alkenes and alkynes, but the saturated hydrocarbon is called alkanes that we explained in the last session. First, alkenes. Alkenes has a molecular formula or structure formula CnH2n, and N is an integer number, and the alkenes is hydrocarbon with one or more double bond. It contains carbon-carbon double bond, but alkanes contain single bond. That's right. First, a naming of alkenes. A naming of alkenes is same a naming of alkane, but has some different details. First, we will find the parent chain, and the parent chain. I told you that the parent chain is the longest carbon chain, but it must contain double bond. So the parent chain here in alkenes, it must contain or include a double bond. This is the first step. And the end will change from ANE, okay, to ENE. So as a step number 1, we will find the longest carbon chain, that's called a parent chain, but it must include a double bond. And we will name like alkane, but we will change the end from ANE to ENE. Okay, this is the step number 1. Number 2, we will numbering the parent chain from the carbon that close to the double bond. Okay, so the numbering here from the carbon close to the double bond. Step number 3, we will name the alkyl group if it found. If we have side branch group, we will name it as like the alkenes. Okay, let's show together some examples. Okay, here we have these examples. We will start the numbering. We will found no branch here, so this will be the parent chain. We will begin the numbering from the carbon that close to the double bond. This is the first carbon close to the double bond, so we will begin the numbering for here. So we have here 1, 2, 3, 4 carbon. 4 carbon, it will be butane, but we will change the end, so it will called butene. And the carbon that contain double bond, it's carbon number 1, so the double bond will be at carbon number 1, so this compound is called 1-butene. We must put the number of the double bond, okay? So 1-butene, but because we have 4 carbon, and 1 because the position of the double bond. Another examples. Okay, we have here 1, 2, 3. This is 3 carbon, so it will be prop. Okay, this is the first step, and it will be propene. Propene. We change the end. Okay, the numbering will begin from this carbon because it's close to the double bond. So this carbon number 1, so it will be 1-propene. It will be 1-propene. 1, this is the position of the double bond, and prop because we have 3 carbon, and this is and ene because we have here double bond. Example number 2. Okay, we have here 1, 2, 3, 4 carbon, so it will be but and butene, and the numbering here is the same from this carbon or from this carbon. It's still the same. Because the double bond, it will be at carbon number 2. We will call the number of the double bond from the carbon before it, not after it, okay? So it will be at carbon number 2, so it will be 2-butene. Okay. Here we will find the longest chain that has the double bond. It will be this chain, okay? This is the parent chain that contains the double bond. And we have here 2 substitution or 2 side chain, okay? We will begin the numbering from this carbon because it's close to the double bond, so it will be number 1, number 2, number 3, number 4, number 5. First, this is 5, so it will be bentene, benzene and the position of a double bond at carbon number 2, so it will be 2-benzene. And we have here two methyl group at carbon number 2 and carbon number 4. So 2 and 4 dimethyl, because it's 2 methyl, so it will be dimethyl 2-benzene. Okay, 2 and 4 dimethyl 2-benzene. Okay, in the last session we talked about the isomers of alkanes, and it compound have same molecular formula but different in the structure. We have here in alkanes two types of isomers: positional isomers and geometrical isomers. What's the difference between positional and geometrical? First, positional isomers. Positional here is referred to the position of the double bond. So the difference here between the two structures is the position of the double bond. For example, we have here 1-butene and 2-butene. This means that the double bond here at carbon number 1 and the double bond here at carbon number 2. So this is two compound with same molecular formula but different in structure, and the difference here due to position of the double bond. So here this is the double bond at carbon number 1, and here the double bond at carbon number 2, because it's called 1-butene and 2-butene. The geometrical isomers. The geometrical isomers is different from the ways of the attachment to the carbon. We have here 2-butene and 2-butene, but here this is cis-butene and this is trans-butene. What's the difference between cis and trans? Cis meaning at the same side, but trans meaning across. So here cis-2-butene, the 2-methyl group at the same side, but here trans at the opposite side. This is across one. The properties of alkenes. First, the alkenes is liquid at room temperature, but alkanes is solid at room temperature, and it has low melting point than alkanes. Okay, so it liquid at room temperature and has low melting points as alkanes. So the question here, why oil is liquid at room temperature and butter is solid at room temperature? Oil is liquid because oil is alkenes, but butter solid because butter is alkane. So the answer will be because oil contains unsaturated alkene while butter contains saturated alkane, which has high melting point than alkenes, make it solid at room temperature. So this is solid because this alkanes, and this is liquid because this is alkene. Another properties of alkene that it can be converted to alkanes by adding hydrogen to the carbon atom. Adding a hydrogen called hydrogenation process. So the process that adding a hydrogen to the alkenes to convert it to the alkanes is called hydrogenation process. For example, we have here ethene. This is unsaturated hydrocarbon. We will add here 2 hydrogen. It will break the double bond to be single bond to be saturated. So it will be ethane CH3. We add the 2 hydrogen, 1 to this carbon and 1 to this carbon to convert it to the saturated hydrocarbon. This is called the hydrogenation process. The alkynes. The alkynes is contain carbon-carbon triple bond. This is the last group, the last main group in the hydrocarbons called alkynes. And alkynes has triple bond. The simplest alkyne is called ethine. Here we have 2 carbon and 1 hydrogen, C2H2. The structure formula CnH2n-2, because we have here the triple bond. A naming of alkyne like the alkenes except the parent chain. It will change from ENE, it will be ended by YNE. Okay. First example here, we have this compound. We will start the numbering from the carbon close to the triple bond. So we have here the triple bond, so the closest carbon, it will be this one. We will begin the numbering from here. We have here 8 carbon, 8, so it will be oct and triple bond, so it will be octyne. And we have here side chain at carbon number 6, so it will be 6 methyl 3 octyne, the triple bond at carbon number 3, so it will be 6 methyl 3 octyne. Another example, we have here 4 carbon. 4 carbon mean it will be biot. Okay, 4 carbon, it will be biot, and the double bond, so it will be, and triple bond, so it will be butene. Butene, and the triple bond at carbon number 1, so it will be 1 butene. And we have here methyl group at carbon number 3, so it will be 3 methyl 1 butene. Another example, we have here the triple bond, so this will be carbon 1. We have here 1, 2, 3, 4, 5, 6 carbon, so it will be hexine, and 1 hexine. And we have 3 methyl group, so this is at carbon number 3 and carbon number 5. So it will be 3,5 trimethyl 1 hexine. This is the naming of alkynes. We have another type of hydrocarbon called aromatic hydrocarbon. And the aromatic hydrocarbon is another type of unsaturated hydrocarbon, so it will have double bond or triple bond, but here the aromatic has double bond. It's a compound contains 6 carbon forming a ring with double bond, and this ring is called benzene ring. Benzene ring, here the formula C6H6, and this is the 3 structure of the benzene. Structure number 1, okay, and this is the ring structure without write the carbon and hydrogen atom, and this is another structure for the benzene. This is the 3 structure for the benzene, C6H6, and it's called aromatic hydrocarbon. Now we must know the sources of hydrocarbon. Most hydrocarbon come from the fossil fuel, and the fossil fuel, it's formed from the remain of plants and animals. So the fossil fuels all is formed from the remains of plants and animals. Examples of the sources of hydrocarbons: petroleum, natural gas, and coal. البتروليوم هو complex mixture of alkanes and cyclic alkanes. So the petroleum is alkanes and cyclic alkanes. But the natural gas contain large quantities of methane and a small amount of alkanes. الهigher alkanes اللي هي up to 5 carbon. So meaning of higher alkanes, this is up to 5 carbon at the chain, and also contain carbon dioxide, nitrogen, and hydrogen sulfate or helium gases. And the coal is composed of carbon. This is the main element in the coal is carbon, and also contain many mineral impurities. This is the coal. So the sources of hydrocarbon: petroleum, natural gas, and coal. What's the ways of producing hydrocarbon? We have 3 ways for producing hydrocarbon: fractional distillation, reforming, cracking. This is 3 processes to produce the hydrocarbon. Fractional distillation is the process that separates petroleum into many hydrocarbons. So the distillation is the process of separation of petroleum. So we will make separation for the petroleum to get us many hydrocarbons. And the reforming is a process that converts large alkanes to aromatic hydrocarbon. So the reforming, okay, is a process that converts alkanes to aromatic hydrocarbons. And the cracking is a process that converts large alkanes to small alkanes and alkenes. So we have 3 ways to producing the hydrocarbons: fractional distillation, reforming, and cracking. This is the 3 ways to produce the hydrocarbons. So now we finished section 1, hydrocarbon, from chapter 18. And if you need to ask me anything, please contact me on the mail. And I hope you understanding this section, and see you in the next session.